Hey Fonzo, what's up? I'll answer your second question now. Just so you know, for the first question, that's how you convert from atoms of nitrogen to moles of nitrogen gas. So, to be able to solve that question, you have to assume that all the atoms of nitrogen in your body are forming nitrogen gas, that they're all part of nitrogen gas, because that's what we're converting. We're saying that all these atoms, this is how many moles of nitrogen gas they would be. So that's how I'd solve the problem. That seems like the most logical way. That really seems like the only way they'd ask it. So yeah, just so you know though, that's assuming that all the atoms of nitrogen form nitrogen gas. So for the second problem, I will explain the relationship between the mass of one atom of carbon and the mass of 1 mole of carbon. So I don't know if your teacher went over this very well, but all a mole is it's just a number. And to be more specific, it's 6.02 times 10 to the 23rd. It's just like pi is a number, and it's just like E is a number. I don't know if you learned about E yet, but all it is it's just this. You can have moles of anything. Apples, oranges, it just delineates a quantity. And it's useful in chemistry because you deal with numbers. This is a really big number, by the way. I know you get that, but you're dealing with atoms that are incredibly small and compact that you need a way to group very large quantities of them. So the relationship between the mass of one atom and the mass of 1 mole, when they're the same element, well, really, unless you're using some kind of weird element, a mole should weigh more than an atom, because a mole is 6.02 times 10 to the 23rd atoms. But the relationship between the mass of an atom of carbon and the mass of a mole of carbon is the mass of the atom is a hell of a lot less. Okay, so I'm going to go really basic because I don't know what you know and what you don't know. So don't take offense to any of this. But under all the abbreviations for the elements in the periodic table is the atomic mass. And the atomic mass, I know you can't read this, but the atomic mass is the weight in grams, the mass in grams, of 1 mole of that element. So all these numbers you see here are for 1 mole, not for 1 atom. They're for a mole. So I'm just taking this off of my periodic table. Yours might be slightly different, but it should be around the same. It should be similar. So the mass of 1 mole of carbon, and you can abbreviate mole, M-O-L-E, you can just write it out, or just write M-O-L. 1 mole of carbon is 12.0107 grams. So to find the mass of 1 atom of carbon, you need to divide 12.0107 grams by how many atoms there are in a mole. And there are 6.02 times 10 to the 23rd atoms in a mole. So just calculating that out, 12.0107 divided by 6.02 times 10 to the 23rd. You get, you should do this out to 6 sig figs. So, 1.9951 3 times 10 to the negative 23rd grams, and that would be the mass of one atom of carbon. And if you want to check your work, you can just multiply that answer saved in your calculator, because if you just write it out like that, you're rounding, because there's a whole string of numbers after the 3. So you just multiply that by 6.02 times 10 to the, that's not 10, 10 to the 23rd and you get the original mass of the moles of the original mass of 1 mole of carbon. So this is the mass of 1 mole of carbon, and this is the mass of 1 atom. Atoms are a lot, well, 1 mole is just a crap ton of atoms, and it's just a way to measure it. There's nothing magical about a mole, it's just a number that we use. And yeah, so 1 mole of any element is going to have a hell of a lot more mass. It's going to have 6.02 times 10 to the 23rd as much mass as 1 atom, because that's all a mole is, a ton of atoms. So hopefully this has answered both your questions. If you need more help, just shoot me an email back or call me. Okay, later, man.